Hi, in this demo, we're going to take a look and see how the healthcare chatbot application implemented in Axway Amplify Fusion's AI Gateway, implementing an agent tool loop API, was actually created. So if you haven't seen the demo, go take a look at that. It will make more sense. But one component of the demo was having the chatbot users log in with auth code plus PKCE. They were logging into a Keycloak auth server, and you see I have a doctor, I have a nurse, and I have a hospital admin. Again, very similar to the LLM orchestration demo. But I'll go through it anyway. So I have a doctor, and if I look at the role mapping, he has or she has a doctor realm role, and likewise for the nurse and the hospital admin. And if I look at the realm roles, you can see I've got a nurse realm role, a doctor realm role, and a hospital admin. So that's how I'm able to determine the role of the user. And that in turn lets the LLM know what tools they could use via a fairly complex prompt. Okay, so that takes care of that. Also, a main component of the demo was also the chat conversations, and I had several conversations. So there were 3 logged in users, but in one of I think when the doctor was looking up appointments, you got an error saying start a new conversation. So I think one of these is a doctor with 2 different conversations. In fact, if I look at the actual data that's being captured, this is a doctor, right? So the role is always doctor. And if I look at the next one, it's probably also doctor. And then the other conversations are the nurse. So you can see the nurse, and that is the hospital admin. So the conversations are stored in Postgres. Again, this is the same mechanism, actually the same components that were used in the LLM orchestration demo. And the last major sort of back-end piece to this is the FHIR database. So this was just a mock FHIR, F-H-I-R, healthcare database following the FHIR spec. And it also exposes a FHIR API, which the Fusion API is calling using its OpenAPI client. So we'll see that. But here is the FHIR spec, and I'm using the patient. So there's a get patient by ID, and then there's also there's a get patient by ID. Excuse me. This is the search patient when I gave the name. That's an example. And again, this mock database has this, dashboard just for manually entering data and also seeing the appointment. If you recall, we looked at the appointment down here, and I can click in and see the details. And again, here were my patients. And if I look at any patient, I can see their vital signs, conditions, medications, etc. So this is where the data was. So it's not that important. And finally, let's take a look at the actual implementation. So here I am in Fusion, and I'll go into the designer, and let's take a look at the healthcare chatbot, healthcare chat conversation API. So again, it has one main API. It also has a remove old conversation cron job to go and clean up my Postgres database. I didn't demonstrate that. It's not so important. And what do we see here? So there's the API that's currently running. That's why the demo worked. And it exposes really one method, a v1 prompt, and that's what's called by the chatbot application in the browser. It also exposes some agent cards because this is actually an agent. Again, I didn't demonstrate any of that. If I go back to the project, you see this is the integration that backs up that post for the prompt, and it in turn calls a post prompt service. So this is where all the action is. We're going to get in there in a second. And there's a couple other services for looking at the authorization header and determining client ID and a role. And there's some other helper methods as well, or services as well. I have the governance rules from API. I have some plugs for integrating with the Postgres database. And then I have a bunch of data objects to help me with my drag and dropping of components in my integration. And as far as connectors, I'm using Anthropic. There's two different models that I tried, but I'm using Anthropic. You need a pretty powerful LLM to deal with the prompt and the requests that are being made. But I'm constantly stepping down the model pricing to see kind of where's the breaking point where the model stops understanding the prompt and requests well. And then I have my Postgres database, and then I have an OpenAPI client, which is used most of the time. There was one operation I couldn't get working with the OpenAPI client, so I created a HTTP client version just for that one operation, which is not uncommon. Sometimes you can't figure something out, or something doesn't work with the OpenAPI client, so you can just use the HTTP client instead. All right, I'm not going to go through every component, but first thing I do is I check to see if a prompt exists. I mean, it should, but I just want to make sure, and if it doesn't, I error out. Then I call the service to get a client ID and user role. Again, we covered this in the LLM orchestration. I pass in a headers object, and in the headers object is an authorization header. And then the response here is going to be the client ID and roles, and the client ID is used as part of the primary key. The primary key is conversation ID and client ID, and there's only one client used here by the web app. And then, of course, obviously, the users are authenticated using PKCE and a login. That's how they actually get the token. All right, let's back over here. Then I get the role. Now, these roles are hard-coded, so the role comes out of the token. But then what I do is, so it comes out of the token, and then what I do is I assign it to a variable here. And this is actually, I think it's a string array. Hold on, what do I do here? Get role. Oh, I think, in this service, I actually do a multi-concat because it comes in as a string array. And here is where I actually do the mapping. So this uses a conditional map. And I check if the string, because it could be other roles. If it contains a doctor, I set it to a doctor. If the string array contains nurse, I set it to a nurse. If it contains hospital admin, I set it to a hospital admin. And I think the default role, is defined here. Yeah, so as the default role is a hospital admin. If the logged in user has some other kind of role that I haven't figured out. So then I create an initial user message, and in here I do the work of creating a conversation or a message array that I'm going to pass in to the LLM. Now, I have to check if there's a conversation ID or not, and if there's not, I create a conversation ID. So this is all about dealing with how we're going to store the conversation in the Postgres database. So it's the logic around that. And then I try to get if there's a conversation ID, then I try to retrieve the conversation from the database and all the error handling around that. Finally, I go into the agent tool loop. This is the important part. Spend more time here. So this is the agent tool loop, and we cannot today in our LM connectors give it a list of tools and say, figure it out yourself, like give it a list of MCP tools or just APIs or anything. So I need to use Fusion and its business logic to kind of feed information to the LLM, and then I have a contract with the LLM. It tells me when it wants me to invoke a tool, then Fusion invokes it and gives the LLM the response. So that's in essence what's happening in this tool. So I have a tool, and if you check to see if you've exceeded the tool limit. So arbitrarily, if there's more than 3 iterations through this loop, I figure either the LLM is hallucinating, or my prompt is not good, so I want to exit out, otherwise this will run forever potentially. Then I call the LLM, and this is kind of important, so I'll spend a few moments here. Basically, all the LLM connectors have a similar input structure. So I have the prompt, and then I have the message array, which I theoretically retrieved from the database, and I appended the new incoming message. But the prompt is pretty important, so let me bring that up. This is a good time to talk about it. And the prompt is also in the GitHub repo, because it is really key to understanding how this works. Okay, because a lot of the intelligence is baked into this prompt. So up here is some general information. You are a clinical assistant for a healthcare organization. You help doctors, nurses, and admins access patient information. You also take tool responses. So you interpret natural language requests and map them to available tools. You also take tool responses and present the response in an attractive human readable markdown. So you can see that into the LLM, I'm feeding request messages, and then it can respond with a response message or a tool request. And then I could be feeding it, the Fusion can be feeding it the tool response, and then it could request another tool call. Or it can take that information, realize that it's done, and it can send a response message back to the user. So that's sort of how that works. And I'm giving us information about how I want the input and output, JSON, object, no extra information. I give it some details about the response format. So if it's a message to the user, I want the type to be message. If it's a request for a tool, I want the request to be a tool call, and I want escaped stringified JSON. Or if it cannot give the information, if the request is not a valid request, I was unable to process your request, etc. I'm doing a single tool call, so I'm trying to let it know not to give me 2 tool calls in a row. And I used AI to help me construct this AI prompt. And this gives more details about the request, some details about how to do the obfuscation, where the user role comes into play, some conversation history rules. And then this is important. This is the available tools. So this is a JSON array of tools. And I make up a name for each tool. And then obviously the description is quite important. That's how the LLM knows which tool to call. Very similar to when you're building an MCP server and you're giving descriptions for the tools, the permitted roles, and then the input schema, and then what's a required parameter. And the output schema for me is always object, because I feed the entire response I get from the OpenAPI request back to the LLM, that can be actually optimized. So there's get patient by name, and again, the permitted roles. There's get patient medication by ID, patient ID, and the permitted roles. And again, you can change these, at will. I just wanted to have a good combination of roles and tools so I can really test out the LLM's ability to decipher all that information. Here's the last one, create appointment. And there's some role enforcement rules. And then here's some example interactions. I think I want to remove one of these because the what can you do? I have one for doctor, nurse, and hospital admin, and I think the LLM can figure it out from the tools itself, but that's why I got that response for asking what can they do. So it's pretty important. And then I take the output, and you can see here that if there's an error, I error out. But if the output is if it's not a success, I error out as well. Then I parse the response, and here I check the type. And if it's a type message, then I exit out and respond back to the user and append to the context database. But, and here's the important part, if it's a tool request, meaning if it's not a message, then it's a tool request. Those are the only 2 responses I'm expecting from the LLM. And maybe that's why when it hallucinates, I get multiples in a row. So here I'm parsing the tool input, I'm invoking an OpenAPI client, and then I'm taking the response and sending it, putting it into a message that will go back into the LLM as a tool response type message. And here's the one case for create appointment where I needed to use an HTTP client. I probably need to just look into the OpenAPI client better and figure out how to use that for creating an appointment. And here's my error handling. And again, over here is where I am updating the Postgres database context window. And that is how we were able to implement the agent tool loop in Amplify Fusion for an AI gateway application for a healthcare chatbot. Thank you.